All right, good morning, everybody. Hope you're doing well today. This is what I had you look up yesterday in the textbook, so let's just go over that. What happens when two parallel lines are cut by a transversal? Which of the resulting pairs of angles are congruent? We described those relationships the other day, alternate interior, corresponding, etc. So what we're going to work with is specifically parallel lines. L and M are parallel. T is a transversal, right? We should have the little markings on there so we know they're parallel. So we got to talk about all these angle pairs. We have 8 angles that are formed. Theorem 3.1, the corresponding angles theorem. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Corresponding angles. That's going to involve all 8 of these angles. I color coded them so we can take a look at this. So where are the corresponding angles here? And I don't know if I like blue more. And let's go sort of pinkish, right? That works. All right, so corresponding angles, right? We have angle 1 and angle 5. Corresponding angles means that they are on the same side of the transversal, same side of the parallel lines. So 1 and 5 are one pair of corresponding angles. Angle 3 and angle 7 are corresponding angles. They're both on the left side of the transversal below the two parallel lines. So these are two pairs. So angle 1 is congruent to angle 5. Let's see if I can do that. Angle, it's not letting me draw. All right, it's not letting me draw there. So angle 1 is congruent. Okay, I'm going to have to stop this because this is crazy. All right, just have to listen. 1 and 5 are congruent. 1 and 5. Let's make sure I got the same right color in. Yeah, hot pink. 3 and 7. Another pair would be 2 and 6. And then 4 and 8. Those are all the pairs of corresponding angles. 1 and 5, 3 and 7, 2 and 6, 4 and 8. Theorem 3.2, the alternate interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. We described what alternate interior meant, right? Opposite sides of the transversal inside the two parallel lines. So here are pairs of angles that are congruent would be 3 and 6. Those are alternate interior angles. 4 and 5 are another pair of alternate interior angles. Alternate exterior angles will be congruent. Now, remember, we defined these angles the other day with just two lines and a transversal. Now it's particular with parallel lines. So alternate exterior angles would be 1, right? Angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. Keep in mind, all the other things that we learned are true here too. 1 and 2 are a linear pair, so they would be supplementary. 7 and 8 are a linear pair, so they would be supplementary. But these are the alternate exterior angles. Same side consecutive interior angles theorem. Now, they're not congruent. Be very careful here. If two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. That means these two angles here add up to be 180 degrees, right? Equals 180 degrees. The same thing with this pair right here. They're supplementary. They equal 180 degrees. And now this one isn't in your book, but I like using it anyway because it's true and it's there. The same side exterior angles. If two parallel lines are cut by a transversal, then the pairs of same side exterior angles are also supplementary. So in this diagram, 1 and 7 added together equals 180. This drawing on here is horrible, but that's okay. And 2 and 8, when added together, equals 180 degrees. This kind of sums it up. It's in your textbook, and it's on this page. You can take a look at them. So let's look at a couple of examples. The measures of 3 of the numbered angles, right, are 120. Identify which angles are 120 and explain your reasoning. Explain your reasoning. So we got to find the ones that are 120 degrees. Right? There's a few angles here. Right? We have angle 2, 3, 4. So what do you know? We have 120 right over here. Right? What's the first thing we know? Well, what relationship does angle 2 and angle 4 have? Angle 2 and 120 and angle 4. They're vertical angles. Vertical angles are congruent. So this one's 120 degrees as well. So angle 4 is equal to 120 by vertical angles. What other relationships do we have? Well, we have this angle here. Let me erase that for a second. This little thing I got's working okay. So go back to the pen. So we said that this was 120. Now, what relationship does this angle have with 5? Well, with angle 5, they are corresponding. So those are corresponding angles. And by the corresponding angles theorem, we know that these two angles are congruent. So angle 5 is also. So we have over here angle 4, vertical angles, angle 5, corresponding. And what other angle would be equal to 120? Well, there's a couple of ways we could go now. 5 and 8 have what relationship? 5 and 8 are vertical angles, so they're going to be congruent, but 5 and 8 are also, right, this one here and here, are also alternate exterior angles. So angle 8 is also 120, that's a horrible 8, by alternate exterior angles theorem. So once you have one angle, you can figure out all of the angles, right? If I wanted to know angle 2, I could find angle 2 as well. How could I find angle 2 if I wanted to? If I wanted to find angle 2, erase that. And go back to the pen, right? The relationship between these two angles is a linear pair. That means they have to be supplementary. If these two are supplementary, 120 subtracted from 180 makes this 60. And that makes this 60 by vertical angles. We already knew this was 120. Right? If this is 60, these two angles are same side interior, supplementary, 120. But we knew that was 120. We knew 8 was 120, right? 67 is alternate interior to this, so it's 60. And these two are vertical, 60, corresponding. So once you know just one angle in this kind of diagram, you can figure out all of the angles. All right, let's put a little algebra in here. How could we find the value of x here? Right? How could we find the value of x? Well, we have to know something. Does this angle right here, let's see, we use that. does this angle, does 115, have any relationship at all to this angle? It does not. However, 115 and angle 4 have a relationship. They're vertical angles. So angle 4 is 115 degrees. Now we know that these two angles are same side interior, so they added together equal 180 degrees. So we're going to set that up, right? 115 plus x plus 5 equals 180 degrees. Combine like terms, x plus 120 equals 180 degrees. Subtract 120 from both sides, and we get x equals 60. So we needed to solve for x, but x plus 5 is 65 degrees, right? So the whole question was, whoop, I didn't want to do that. I wanted to do this. It said just find x, so we didn't even have to put it in that one. X was 60. All right, how about here? Well, here they give us angle 1 only because in the textbook, right? In the textbook, they didn't have that one theorem that I gave you that was extra, 3-4a. We could have went here and found this pair, but we also know that these two angles here, this angle and this angle, are same side exterior angles. If they're same side exterior, they are supplementary, right? So let's see if I can go down a little. So if they're supplementary, I know that 136 plus 7x plus 9 equals 180. All right. 136 plus 9 is 145. So 7x plus 145 equals 180. 7x equals 35, right? That's minus 145 from both sides. Divide by 7. X is equal to 5. Right? And did it just say solve for x? Yep, solve for x. So x is equal to 5. 7 times 5 is 35 plus 9. 35 for 44. And you can check that 44 plus 136 is equal to 180. So we got the answer correctly. Angle 1 is 105. And find angle 4 and angle 8. And which theorem you use. This is similar to the first one we did. If I know that angle 1 is 105 degrees, then I know angle 4 is 105. That's vertical angles. I know that angle 8 is 105 by corresponding angles. Right? And angle 5 is also 105 by corresponding angles. 1 and 5 are corresponding. 4 and 8 are corresponding. 1 and 4 are vertical angles. All right, so this is a challenging question. I'd like you to work on that now, and then we'll go over what the answer might be. All right, I wonder if I can pause this, give you a few minutes to work. Nope, I guess not. So there's no pause. No pause button. All right, I'll stay quiet for a moment, give you a chance to work this out. Just realize that, uh, let's see, and we want, yeah, let me just use that. Right here, even though you only have a piece, this is a whole line, and this is a whole line, and these are parallel lines, right? We have this here as well. It's not quite where I want it, but it's close enough. So if you just look at the left side, you have two parallel lines cut by a transversal. And so if we divide this down the middle, it's fine. Let's use it like that. Let's make it red. All right, if we just divide this down the middle, I have an expression on the left side over here with two parallel lines cut by a transversal. And I have one on the right side, two parallel lines cut by a transversal. So this is, bringing back some of the algebra that you're supposed to know, a system of equations. So I'm going to have two equations, both of which should be either x equals or y equals so that we can solve. So I'm going to be quiet for a moment and let you try to work this out. All right, since I'm doing this in class too, I have given them the time. You guys at home who are getting this, hopefully you've given this a try. You can pause the video here and try it. But this is what it's going to look like. The first equation. Well, let me go back to it. Right? How would we solve this? So just on this left side, right, I've got, I'm going to do it in black, 2y plus 2x plus 12 equals 180. Same side interior angles. I want to get either y or x by itself. I'm going to get y by itself only because I have a single y over here. So how do I get y by itself? Well, I'm going to subtract 2x plus 12 from both sides. 2y equals 180 minus 2x plus 12. And then I'm going to divide by 2, so I get y by itself. Extend the page. So what do I get? Y equals 90. And I'm going to distribute that negative sign. Minus x minus 6. Y equals negative x plus 84. Right? And what about the other side? Well, here I'm going to add these two together and set it equal to 180. 4x plus y plus 6 equals 180. Now I want to get y by itself, so I'm going to subtract 4x and I'm going to subtract 6. I get y equals 180 minus 6 minus 4x. And clean it up just a little bit. Y equals 180 minus 6 is 174 minus 4x. I now have two equations that y equals, right? I have this one. And I have this one. So if two things equal y, the whole idea of a system of equations, I get that this is a tough question. This is sort of a challenge for you guys to do, right? They can be set equal to each other. So what do I get? I get that, I'll do it in black, negative x plus 84 is equal to 1, what was that? 74 minus 4x. So I'm going to subtract 84 from both sides. Minus 84, minus 84. 174 minus 84 is 90 minus 4x equals negative x. Add 4x, 3x equals 90. Divide by 3, x equals 30. So if x is 30, what is y? Well, we can go back and use either one of these equations. I'll use this one, it's a little bit simpler, right? Negative 30 plus 84, y equals negative 30 plus 84, and so y is equal to 54. All right. Which is exactly, it's worked out here. So I will send this, it's a little bit cleaner here, but I just wanted to do it. Divide it by 2 through everything. It is slightly different in this step, but it's pretty much the same thing that I did. Page 135, 136, numbers 3 through 12, and I will see you on Tuesday. Have a great day. I picked the wrong